Good morning to one and all. This is Dr. Sengolrajan, Associate Professor in the Department of Electrical and Electronics Engineering from Ponganadu College of Engineering and Technology, Autonomous Institution. I am going to deliver a content on embedded systems on the titled Direct Memory Access, that is DMA controller, as well as in-circuit emulator ICE. This is the diagram for direct memory access controller DMA, where in the left hand side you will be having a processor. This inside the processor you will having a BIU, that is bit interface unit. Then bottom you will have a DMA controller, that is DMAC. The first line is meant for bus available acknowledge, and this line is meant for bus hold request, where you will have a that is signal lines from processor to the RAM, random access memory. This is nothing but a data bus where an 8-bit data D0 to D7 will be transferred to the A port for DMA operation, as well as address lines from a 16-bit data A0 to A15 will be transferred through these lines. CS bar is nothing but a control signals. Then RD/WR is nothing but a read write. Then this line is from a decoder for memory select. And this is nothing but the port A, where from the decoder port is being selected. And this is nothing but a device to send or receive from random access memory. And IO is nothing but input output lines. Here you are having two lines. One is nothing but a direct memory access request, and the other one is direct memory access controller acknowledge. Here system bus are not accessible by the processor internal address and data lines during the acknowledge active. What is a DMA means? A device that facilitates DMA transfer is called a direct memory access controller. It has a processing element. The data transfer occurs between input output devices and system memory with the least processor intervention using DMAC. The system address as well as the data bus becomes unavailable to the processor and available to the input output device that interconnects to you during using DMAC during the data transfer. Then how this direct memory access channel, in case of a multiple interrupts, if there has been occurring, how it is being taking place, how the channel is being selected. The direct memory access based data transfer service is being very small latency period. The latency period is very small compared to the data transfer using multiple input output interfaces and multi-byte bulk or burst transfer. That means the multiple input output interrupts and multi-byte bulk or burst transfer. Compared to that, this DMA will be transferring the data in a very small time. That is, the latent speed is being very small. Then, as well as the ISR will start and it will, the time period of the ISR will be very small. It will initiate the DMA using the command data code memory block as well as input output bus start address. Then what about a DMA controller? It sends a hold request to CPU as well as CPU acknowledge when the memory buses are free. It will operate in DMAC will operate in three modes. One is a single transfer at a time. At a time, it will transfer the data and as well as release of the hold on the system bus. Bus transfer, second mode is bus transfer. It is as well as transfer the data at a time and release on the hold on the system bus. It will be the transformation will be in terms of kilobytes, whereas bulk transfer, it will transfer the data release on the system bus after once the transfer is completed. Then the DMAC is programmed for read or write as well as transferring the data in terms of bytes, burst or bulk. The number of bytes to be transferred in its data transfer count register and for starting the memory address. For starting the memory address, there are three modes as I said earlier. One is burst mode, cycle stealing mode, transparent mode. That is burst mode means the bulk data in terms of kilobytes, the data will be transferred. Cycle stealing mode, that is a medium rate data transfer, and transparent mode means the next mode of a transformation. Coming to the advantages of DMAC, the computer system performance will be improved when you use DMAC for data transmission using the input-output devices. Then CPU is free to perform the operations when they do not use the system buses. Disadvantages is nothing but the burst during the burst transfer mode, the CPU is rendered inactive. CPU is rendered inactive. So the bulk transfer as well as a single transfer will be having the advantage in case of DMAC. Coming to the applications of DMAC, whenever if you want to transfer a large amount of data as well as the latency speed in a very small rate, yeah, we can go for this DMAC. The examples for DMAC is hard disk, CD, video memory to refresh display, sound cards, network cards, and data acquisition boards. Next, we are moving on to the title, that is in-circuit emulator. In-circuit emulator, from the name itself, we can be able to recognize that in-circuit within the emulator, within the circuit, we are going to embed a chip, embed a chip. That's why it is called within the processor, we are going to embed in the circuit. So that's why it is called the in-circuit emulator. Then in the place of a target circuit, this ICE, that is in-circuit emulator ICE, will provides a greater flexibility and is for developing various applications on a single system in place of a testing multiple target systems. This ICE, it is a circuit for emulating the target system that remains independent. It is not dependent. It is independent of a particular target system processor for the most of the target system, which will incorporate a particular microcontroller chip. Only based on the controller chip, what that is being embedded into the processor, based on that only this IC will be working. It is independent of the processor. Independent of the processor. This chip that you can be inserted into the processor using the serial link. Then it is an emulator of a microprocessor of target circuit which connects the host system via a serial link for debugging the process. The various versions of the microcontroller family during the development phase, as well as using the remaining part of the target circuit, it can emulate. It can emulate. Then how the interfacing will be done means for in downloading the ROM images into EEPROM and RAM bytes from the host system into the emulator, this IC will be useful. It uses the COM RS232C for serial linking port of PC for linking the data. It helps in embedding in the program memory port the large application ports directly from the PC. Ports will be developed on the host using the high-level language. Then the purpose of socket, it is a multiple male-female socket to insert a general purpose processor, DSP, embedded processor, or a microcontroller which connects to ICE through a cable and a connector. That is the socket that will be suitable for ICE to insert to perform the target. The next, there will be a external memory. External memory. That external memory is nothing but an additional RAM as well as the electrically programmed read-only memory or electrically erasable program read-only memory will be used for targeting the system as well as its applications. And coming to emulator board display unit, it uses a single 8 or 12 character display. One by one, the address will be executed. Then 20 keypad, 20 key keypad, that is, it is used to enter the data as well as ports directly to the user and locally at the memory addresses. Coming to the register, the purpose of the register, it is an additional system register for the single step as well as full speed test runs during the testing of the system. Then purpose of the connector to plug in the emulator to the interface circuits and the other devices as well as the peripherals that connects to the system. And the use of target system keyboard user input board equivalent to the target system as well as the expected keyboard. Then target system driver circuit, for example, driver hardware for network, motor, solenoid valve, furnace, or printer. Then coming to the monitor ports, these are all in the emulated EEPROM, as well as the target system room to test and debug with the actual target process or microcontroller and the target circuit. Here you will have a diagram of the in-circuit emulator circuit, where this is nothing but a PC. To the PC, you can be able to transmit the data as well as receive the data via the connecting cable. That is nothing but a RS-232C via the port, serial port. And this is nothing but a microcontroller with along with the memory, that is the random access memory with the interfacing circuits. You are plugging the ICE to the ROM emulator, which connects to the processor via the RS-232 cable, or you can be able to transmit the data as well as receive the data. So similarly, you can use microprocessor or microcontroller that is being plugged into the processor. You can use as an ICE. So within the processor that you are being, that is, it will be just like an USB. A USB that is being inserted to the PC through via a port, it is being performing the process for the target system. That's all. Thank you. We have been discussed the in-circuit emulator as well as the direct memory access controller.